Hey folks, Buckley here. We're going to do a quick tutorial in Microsoft Excel on how to compare groups with some of the inbuilt functionality of Microsoft Excel. So first thing I want to do is have you check that you have the correct tool added into Microsoft Excel. So you want to go to Tools, Excel Add-ins, and then make sure this Analysis Tool Pack is checked. Okay, all you have to do is check it, and then it's going to show up. Okay. So just make sure that that is turned on because we'll need some of that functionality. All right, next thing we're going to do is take a look at our data. So we have a variant of the data set that we worked with last time. Last time we had 50 samples. We'll have 30 this time, 30 samples of rubber bands. And we've got different stiffness values for 3 different types of rubber bands. Okay, so 3 different types, type A, type B, type C. Okay, 30 samples of each, and these are the stiffness values that we measured. So what we're going to try to do here is determine if there are statistically significant differences between the stiffnesses of each type of rubber band, right? So we're trying to figure out if there are differences between groups. So we're going to start out with our usual descriptive type statistics. So let me do type. I'm going to make a little simple table. A, B, C. Okay, mean, this will be in newtons per millimeter, and standard deviation in newtons per millimeter. And then just as a good reminder, okay, this is just a reminder on how to do this, we're going to use our inbuilt functions. For mean, we have to use the average function. Okay, we're just going to select down. There we go. For B, average again, that's going to be this column. And then for C, here we go. And then we'll do the same for the standard deviations. Standard dev. Okay, we'll take this column. B. And I'll show you in a sec how there is some features in Microsoft Excel here that'll allow you to do this quickly. It'll generate a little table for you. I'll show you where that data is. But for right now, we'll just go ahead and do it by hand. Okay, this is also a good reminder that these are the incorrect number of significant figures. Okay, so our data here is presented to 2 sig figs, so we're going to make sure that both mean and standard deviation are presented to 2 sig figs. So I'm going to go ahead and use a shortcut key, but you can go Format Cells, okay, is what I'm doing. I use the Command 1 key to bring that up automatically. Okay, so I would just go to number, decimal places 2, there we go. And I'm going to change this up a little bit. I'll put stiffness here, and I'll put my units. I'm going to go ahead and merge those 2 cells together. Okay, this little button here merges the cells. So a little bit of formatting for you. Okay, so if I wanted to present this in table form, that would be a neatly formatted table, right, of those results. Okay, let's scan this a little bit. So we can see that type A and type B are fairly close, 0.85 and 0.95, with a standard deviation of about 0.16 to 0.2. Okay, so those may be different from each other, they may not be. C is really an outlier, so 1.32, standard deviation of 0.31, so that's much higher, but the standard deviation is bigger. Okay, so we'll see how these results pan out. So the first thing we're going to want to do is we have 3 groups here, A, B, and C. So in order to compare these groups, we first have to check if all of these belong to the same population or there's a different population in there. So that would require, if you go back to our workshop presentation, we have more than 2 groups, therefore we're going to run an F-test, regardless of the sample size here, which is 30, which is right on that cutoff between an F-test and a T-test. We're going to make sure that we run an F-test here, or an ANOVA for these 3 groups. So in Microsoft Excel, this is a good chance to use this advanced feature. So we're going to go to the Data tab, then you're going to go to Data Analysis. So under Data Analysis, you're going to select ANOVA, Analysis of Variance, Single Factor. This means one-way ANOVA. Click OK, and another tool comes up. Okay, so what we want to do now is select the data. So I would select all of this data. You could select those headers there too, type A, type B, type C. Just make sure that the labels, you check this labels in the first row. That'll let it know that this first row that I've selected is not data. They're the labels for that data. Alpha is my significance level, is 0.05. Okay, output range, this is going to be where it wants me to plunk down the data. So I'm going to have it start in F8. Okay, you could also have it be a new workbook if you want, but I'll have it embedded. So then I'm going to click OK. All right, and this nice little table comes up. So this is the ANOVA, this is the statistical analysis that was run. Okay, and our critical value is right here. So I'm going to go ahead and highlight that. Okay, so you'll notice our F value and our P value there. That P value is very, very small. So I know for a fact now that these are not all going to be part of the same group. So I have a P way, way less than 0.05, which is my cutoff. That means that I have some differences between these groups, but I don't know which groups are different from what. Okay, so to do that, I'm actually going to go ahead and I'll run a t-test. So again, I'm on the cutoff with 30 samples. I'm on the cutoff between t-test or f-test. For this type of direct one-on-one comparison, I could do either one. I'm going to do a t-test just so I could show you another function here. If you were to run an f-test, you would basically rerun this same analysis, but you would select, let me show you, you would select actually just 2 of the columns. So instead of doing all 3, I would just select 2 out of the 3, okay, and that would compare type A and type B directly, okay, and that output. So that would be how I would run an f-test for just those 2. Okay, I will warn you actually, this is a good chance to warn you. So there is an f-test in here, f-test 2 sample for variances. This will actually spit out the one-tailed f-test value, which is not what we want. Why Excel is doing this, I have no idea. It is poor, poor, poor statistics. Okay, so I would prefer that you rerun the ANOVA, which is up here, and not the f-test down here, because that's actually a one-tail instead of two-tailed. Okay, so let's run our t-test. So we're going to do pairwise t-tests. And the pair that we're doing, so we'll have AB, AC, and BC, okay? And I'll have the p-value that's going to come up, and then I'm going to go make sure, just remind myself, I'm going to adjust the p-value, right? So I'm going to do that Bonferroni adjustment, and we'll talk about how to do that. Okay, so for AB, I'm going to use there's an actual command line driven equation in Microsoft Excel called t-test, okay, and it takes a couple inputs. So it takes the 2 arrays, so I'm going to select A, okay, then I'm going to select the data for B, which are the 2 that I'm comparing. Then the next option is tailed, so one-tailed versus two-tailed. This is a two-tailed, folks, okay? So remember, by default, we're going to assume 2 tails unless we have a really compelling reason why we think one outcome is always going to be greater, one group is always going to be greater or less than the other, which is pretty rare. Okay, type. Okay, so for type, we don't have any pairing, okay, so we haven't repeated measures, paired, or matched. What we do have, the best assumption here is 2 sample equal variance, okay? You could select unequal variance. This is for situations where you have drastically different sample sizes or variances. We do not. Our variances are fairly comparable, so I'm going to select 2 there, and I'm going to hit enter. Okay, so my p-value for this guy is 0.02846, blah, blah, blah. Okay, I would probably present that to just 3 significant figures, so I'm going to go ahead and reformat that right away. Okay, so 0.028. All right, now let me do this again. Now I'm comparing A and C. Two-tailed distribution, equal variance. Okay, that guy's coming out really, really small. Let me go ahead and, there we go. And then the last one, I'm going to compare B and C. With a two-tailed distribution and 2. Okay, again, that's going to be really small. Really, really small. Actually, I'm just going to go ahead and take those off. I'll just display the whole thing. Okay, All right, so now I want you to remember that you have to make a sacrifice to the statistics gods here when you do multiple comparisons, multiple pairwise comparisons. We've done 3 pairwise comparisons, which means that my threshold for significance is going to be 0.05 divided by 3. Another way to think of that is to multiply your p-value over here by 3 and still compare it to that 0.05 cutoff. So I'm going to go ahead and have my adjusted p-value be this guy times 3, which is the number of comparisons that I'm making. Oops, sorry, made a mistake there. Okay, and I'll do the same here and below. Okay, so this is this guy times 3, and this is this guy times 3. Okay, so what we see here is that the difference between A and B, okay, A and B, which appeared to be significant at first, actually is not significant when we adjust for, so here it's less than 0.05. When we adjust for multiple repeat comparisons, it's actually not significant. So I would probably still report this p-value, but I would not consider it to be significant in my plotting. Okay, so what we have here is that A and B are similar to each other, and they are both different from C, is what I'm concluding, because A to C and B to C are still significantly different. All right, now let's take a minute to remind ourselves how to make bar charts and how to add statistical information onto them. So let me show you how to do that. So we're going to start by going ahead, and I am going to insert a bar chart. I'm going to make sure that this chart is moved to its own page. All right. Now I'm going to clear this data. I'm going to put in my values and select the mean as my value. So what I'm still plotting is mean and standard deviation, right? My horizontal x-axis labels are down there. I'm going to select OK. All right, this chart needs some work, right? So let's get this into the right formatting and remind ourselves how to do it as we do it. Let's see, make sure that I have a line, make that a solid black line. I'm going to up the size here. Okay, I will leave the scale for a second. I'm not going to leave it to 2 decimal places, but I want to show you it's best to hold the scale until after you put the whiskers on for the standard deviation. Okay, I think that 18. I'm going to fix this. I don't like that color. Make it a nice medium gray. I'm going to get rid of all of the border. Okay. I'm going to add in my axes. Stiffness, Newton per millimeter. Okay. All right. Now I'm going to add those whiskers in. They're called error bars in Microsoft Excel, but we know now that those are definitely not errors. It's just natural variation there. Okay, we're going to set that equal to plus or minus the standard deviation. So I'm going to copy that for when I put it down in the negative value. Okay, and then that's that value. All right, now's a good time to go ahead and change my bounds. Make this down to 1. Looks good to me. Okay, all right. Last thing I might do is change the gap width a little bit. There we go. Make them a little bigger. Okay, so now it's time to add my statistics on. There are a couple ways to do this. I would prefer, this is a nice clean case, so I'm going to go ahead and I'm going to show you how to do this with lines. So I'm going to insert, in this case, you're going to just put a little illustration in there. You're going to put a line. Microsoft Excel isn't really as good as Word with the art, but it does okay. Okay. Copy that. Do something like this. To show that we have a significant difference between the groups. Last bit would be to add in a text box. It'll be over here. And I'll just put a little asterisk. I lost my text box. Okay, and I'm going to make that nice and big. That would illustrate that these A and B are similar to each other, but it's different from C. The other way to do it, gang, and I'll just show you this, is that I could take these off and I could go with that designation where I'm saying that anything that shares a common designation is not different from the other. I'm fine with this as well. Okay, let me show you how we would report some of this data. I think that's important. Okay. So under methods, I would say that one way ANOVA was performed to compare stiffness across rubber band types. MS Excel is the software that we used. Pairwise t-tests were performed and a post hoc adjustment was applied. P less than 0.05 was the, that's a little p, folks, so make sure it doesn't capitalize, was the cutoff for significance. Results. So really the main finding here, okay, is that type C is substantially stiffer than types A and B. Okay? I might say something like that. If you want to highlight what these values are, you could say type C rubber bands were substantially stiffer, were 1.32 plus or minus 0.31. Okay, now to get that plus or minus symbol, okay, there's the cheating way, which is to do plus and then underline. Okay, the non-cheating way is to use an insert. So I would go insert, equation, oops, not equation, insert, symbol, advanced symbol, and then I would select the plus or minus, which is always tricky to find. Hello, plus or minus. Oh Lord, where are you? I always have to search for you. Divide by, it's in here somewhere, I swear. Just want to say it's somewhere in the middle. Anyway, I am not locating it at the moment, folks, but it is somewhere on here, I assure you. Anyway, I will do the cheating way. There's my plus, and there's my underline. It's usually good to also say that you are presenting mean and standard deviation. Okay, now let's add in our figure. I'm going to do this the cheating way too. I'm just going to do a screenshot because this is nice and big, but you could export it as a PDF if you want. Okay, and I'm going to come over here and I am going to insert this guy. It's very important at this time, folks, to remember that you have to explain the statistical abbreviations that are included on your graph. So, and you also have to say that the whiskers represent plus or minus 1 standard deviation. Items not connected by similar designators are statistically different. P less than 0.05. Pairwise t-tests with post hoc adjustment. Okay, so that completely explains what's happening with the stats there, and that's very needed. All right, guys, that's what I have for you. Hope you enjoyed that. Good luck with your formative.